Here we have a SAT math problem. Okay, let's go the question. X times 4k negative 15 positive 19 equals to 53x positive 47. In the given equation, k is a positive integer. If the given equation has exactly one solution, what cannot be the value of k? Before we start solving this problem, let's look at some stuff on solving a linear equation in one variable. Let me write the equation first. That is a1x positive b1 equals to a2x positive b2. Here we have a linear equation in one variable, that is x. This is a1, b1, a2, b2. All of them are constants. Now we can consider three possible cases for the solution of this linear equation, that is the value of x. The first case is the equation over here has exactly one solution. If this equation has exactly one solution, then the coefficient of x on the left side, the coefficient of x on the right side cannot be equal. That is a1 and a2 cannot be equal. In that case, this linear equation will have exactly one solution. We don't have to worry about the values of the constants b1 and b2. They may be equal or they may not be equal. So if the equation has exactly one solution, the coefficient of x on the left side, the coefficient of x on the right side cannot be equal. Now let's consider the second case. That is, this equation has infinitely many solutions. Then the coefficient of x on the left side, the coefficient of x on the right side must be equal. And also the constant terms must be equal. That is, the value of b1 and b2 must be equal. So in this case, this equation will have infinitely many solutions. And the third case is the equation has no solution. In that case, the coefficient of x on the left side, the coefficient of x on the right side must be equal. That is, a1 and a2 must be equal. And the constant terms must not be equal. That is, this b1 and b2 cannot be equal. b1 is not equal to b2. So these are the three possible cases we have for the solution of this linear equation. So the first one we have for exactly one solution, and the second one we have for infinitely many solutions, and the third one we have for no solution. Okay, the equation we have over here is a linear equation in one variable. It is exactly in this form, and there is an information the given equation has exactly one solution. Since the given equation has exactly one solution, we have to consider the first case. That is, a1 is not equal to a2. That means that the coefficient of x on the left side, the coefficient of x on the right side cannot be equal. Let's consider the coefficient of x on the left side. That is 4k negative 15. And it cannot be equal to the coefficient of x on the right side, that is 53. Now let me add 15 to both sides. Let me do it. Then this negative 15, positive 15 will cancel out. I am getting 4k is not equal to, when I combine these two values, I am getting positive 68. Let me divide both sides by 4. Then this 4 will cancel out. K is not equal to, when I divide 68 by 4, I am getting 17. When the given equation has exactly one solution, then 17 cannot be the value of k. We find 17 in answer choice A. The correct answer choice for this question is A.